Okay, welcome back. This is the part 2, basically showing how to make a cut with the machine. I previously went to my workplace to make a small G-code file with MasterCAM, used a milling machine post-processor, and used or made the G-code file so that the tool is already compensated for its diameter, meaning the tool in this case is 0.3 millimeter in diameter, because the Arduino can't calculate the needed compensation on the fly. And I'm using Realterm to make my file transfers and using a small delay per character to allow the Arduino to have time to save it on the SD card while it is receiving the information. And from the controller I can select NC, receive, and now I give it a name. Let's see, let's put a test, hit start, it's waiting for the file, and now we can select send file, it's sending, it's saying receiving. It should receive about 1 kilobyte file. The faster way to do transfers is to pull out the SD card and just get all the there we go. Get all the data on a computer to the SD card and plug it in. So it got 977 bytes. Okay. This is a small bug in the programming. It should clear out the display. It's basically now waiting for start command. We can put the wire traveling. It doesn't require much speed. That's about okay. And we can select that we have about 70 volts or so. I tend to use the manual mode to fill the work tank. So let's open our connector here and let's hit flush. Sorry, that button. And it is now trying to fill up the tank. It's kind of loud, but considering that this machine sits in its own room, it doesn't matter. And the small piano wires kind of sound comes from this because it's pulling at an angle, so it kind of drags on this wheel here. Nothing to worry about. We're almost full. And I have my X and Y zeros at that point. And we are now full. It's overflowing to the dirty water tank. I can close this, and the pump is still on. It's showing the flushing coming from the lower guide. So I can now go back to the NC mode, select file, Next, that's our test file. We hit select and start, and it should now switch off the light. So it's now machining at full speed. Full speed meaning that it goes as fast as it can. The display is already crapped out. It tends to do this because of interference, and because this is only a plastic case, so it doesn't protect from the EMF at all. Yeah, that's the machine working on its own. The wire feeding slowly. I think about 1 meter or 2 meters per minute. I usually tend to watch out the wire here, where it's coming off from the machine. If it's looking very ragged or a moon surface, it's about to break. But looking at the spent wire, you can see the original new wire here is the nice bright colored, while the used wire is kind of dull. Let's see if I can get a small close up here. Get this to focus, please. No, sorry, I can't get it to focus, and that the problem is because that is below water, so it has a kind of a hard time to focus and process. The shape I programmed is just a small, about 6 times 7 millimeter piece that has a couple of holes, lead in, lead out, a huge radius, one chamfer, the basic kind of stuff for demo. And the most important part in building this sort of machine is that you have the wire going through these wire guides as tensioned as possible, so it is always straight and it doesn't wobble in any way. And also the wire that comes from the spool has to be coming kind of straight, so it doesn't jerk around from the spool, because that affects the cutting. The wire momentarily makes a wave, and the machine can kind of lose its track of what it's doing. At the moment it's cutting one of the holes. You can kind of see a small cut there. That's 0.3 millimeter wide cut. And as you can see, I also previously cut some parts out of this piece. It's now showing what I said, 70 volts gap. So the Arduino measurement circuit that I explained previously kind of works very well, considering that it's quite a hack. There's namely not anything regards to the current. It's showing barely quarter of an amp or so, not much. The wire can handle something like 3 or 4 amps easily. The small pause in that cutting action actually was when it entered the circle, made the circle and came back. From the same place it went in. The moment it went around the circle, the piece of circle in the middle flew away from the flushing water, and the machine didn't of course cut anything because it was already going back the same point or same line that it went into the cut. And you can here see also that this is a very easy machining process in terms of actually putting things in, because the piece I'm holding here is just loosely clamped with one clamp from far away from the actual working condition. This is the reason because wire EDM or EDM process, so that's electrical discharge machining, what you can see there, a spark, is a contactless process. The wire doesn't contact the workpiece at all. There's always a small gap that the spark will jump in and eat the metal away. So because of that, there's no forces acting on the tool, the wire, or the workpiece. The only force you will have is from the actual flushing. So if you would have several bars of pressure, yes, it would bend small pieces, but I mean, I have just a small supply of water to get all the debris out. I'm not doing some very thick cuts which would require a hefty amount of pressure to flush correctly. This is a hobby machine. Just remember that, a hobby machine. It works, it cuts very accurately and with very consistent results, and for my needs it's very good, and especially this is my first wire EDM that I have ever built, so my apologies. But yeah, that's the second pose, that was the second hole that it cut. The workpiece, as I said, it's aluminum, so it kind of tends to cut very fast. The usual I have been getting from this stuff is something like 14 square millimeters per minute cutting speed. I think the longest cut that I have made, I have some examples of things I have been cutting here, is this. I cut this sign or nameplate or whatever you want to call it to my friend Holly. It's 20 millimeters thick aluminum, and it took many hours to cut, but no problems there. Went just fine. You can see the lead in here. I kind of liked to start away from the workpiece instead of drilling a hole and threading through the hole and starting from there, but sometimes you have to. Or the lock enthusiast might recognize this is the easy entry blank, blatantly copied. Just tested it out. This was with me year before in LockOn. Of course, a bottle opener. This is probably the first CNC cut that I made completely without any failures. Then I have been making some jewelry. This is cut from stainless steel. It's a small cat from open clip art, and I used Inkscape to get me a vector graphics outline of this cat that I then plugged into MasterCAM. This is also cut from stainless, a small, very small piece that's like 1/2 millimeter thick on the ring. It's for a lockpick tool, meant to be soldered in place for a 2-in-1 pick. Then I have been cutting nameplates. This was a test, didn't succeed. Actually my wire broke, so just before it finished. Then because this process doesn't care if you're machining soft stuff like the aluminum, like that. Actually that's almost done. Yep, almost done. Or high-speed steel, like extra hard steel, tool steel. The machine doesn't care. It cuts at full power all the time. And this is one example I have also cut. It's a Lock-on logo. This was a little fuck up. I actually made a better one for my friend. The machine has now finished cutting. It's still running the program through because there's some lead out also. So that's the lead out. It's already out of the part. The part has dropped, and that's the end of the program. Now I don't have a switch, so I just plug off the power and shut down my controller. And now I can pull the overflow pipe out, and you can see that it cut just perfectly. You can see the part down there under the wire guide. It has dropped in there. That's one of the reasons I would like to redesign this machine, because the wire is traveling very near the bottom. So if something drops and gets caught between the wire and the frame of the machine, it makes a short circuit and the machine stops. So that's not good. There should be a few centimeters at least of space in there. But as I said, first wire EDM, first prototype, and let's see if I can fish it out. Okay, let's see. A surface here, and there's our part. I'll have to get something better behind the little contrast. Here we go. Now, the reason why there is a small, that should be straight cut from the lower right corner up to the point where it lead in is, I think the piece that I was cutting out of had some previous cuts. Yeah, it kind of fell off because the material ended. You can see there. I was too close to the edge of the workpiece, so it fell off prematurely. But yeah, you can see the two small holes and the two very small cuts that I made into the holes. Those cuts are 0.3 millimeters wide. The other is in the center of the circle, the other is tangential to the circle. In that corner is the 1 millimeter chamfer I made. That's 5 millimeter radius on the outside. The circle diameters are just free-handed. I don't know what they are. But yeah, it's a small part. Let's see if I can get a small. I don't know how well you can see that. The cut quality is very good in aluminum. There is no discoloring. It's always very nice and sharp. For cutting something other than aluminum with this machine, like the high-speed steel I showed you earlier, because it's water in the work tank, and water and steel just doesn't mix very well. The cut area tends to rust if it's in the work tank for prolonged periods of time. But for most part it doesn't matter if you dry it out immediately. This is something that has been sitting in the machine for hours and hours and hours during and between cuttings, so it has rusted a little. Stainless steel also doesn't rust, of course, but it at least shows the color of the cut. Come on. You can see it's stainless, quite nice and shiny, but the cut surface is a little dull or brass colored, because the wire tends to leave the brass residue on the part due to the electrolysis that takes place. That's not a problem. If you want to have very nice and looking part, you can sandblast these or use some glass beads to blast these after cutting, so you also get all the very sharp corners away. But yeah, that's about it. Small machine, but it's working fine and needs improvements. The wire pulley system, I would like to replace the wire pulley unit with the one that pulls it straight through a small tube and off from the machine to a trash can or a small clipper that clips the wire into small pieces that actually don't take much space. But that's a work in progress. And also I have to make the work tank a whole lot deeper and replace the wire guides with the bought ones, commercial wire guides. Those work, but I would like to make a 4-axis wire EDM someday, so that kind of requires something other than the homemade ones. These work just perfectly and fine for 2D cuts like these. The cost of making those is, for materials, it's like pennies. It doesn't cost anything. The whole machine itself, everything that I have bought, I would guesstimate about 1,000 euros. All the parts, all the pieces, all the metal, all the connectors, everything, and countless hours of assembling, machining, fitting things together, figuring out my errors, making a nice controller box that doesn't fit all the components. Yeah, that's the kind of thing that you do when you're prototyping, but I'm sure you guys will know what prototyping means. Okay, that was the cut. I would like to thank you for listening and seeing what the machine does when it does. And if you have any comments or anything, just send them to my email down below. I read that a lot more than the YouTube comment page. And please tell me what would you like to see or hear, or what kind of improvements would you like to incorporate to a machine like this? Because I have a few ideas, but they are work in progress and require quite a lot of time to make, so they're not happening this week. Sorry. But yeah, thank you and see you in the next video.